Hi, I'm Emily Lakdawalla from the Planetary Society. In a past snapshot from space, I talked to you about the huge treasure trove of data that's just waiting for people to explore. Today, I want to give you a sense of just how much data there is. I'm going to use the example of Voyager 1's flyby of Jupiter. This happened in 1979. I checked JPL's website, and there are about 100 images of Jupiter released from both the Voyager 1 and the Voyager 2 flybys. Then I checked NASA's archives and found that there were 33,000 images in total that the Voyager spacecraft took as they flew by. So what's up with that? Why is this data not available? Why are we not seeing all of these images? To answer that question, I thought I would show you some of the raw images from Voyager 1's approach to Jupiter. As you can see, they are not very pretty, and there's a number of reasons that they're not very pretty. First of all, it's just the physics of the flyby. Voyager 2 was moving constantly, so was Jupiter, and so were all of its moons. As a result, none of the images are very well aligned, and Jupiter keeps growing in the field of view, so it's actually extremely difficult to line the images up to make beautiful color pictures. A second reason has to do with the somewhat old technology that was on these spacecraft. Voyager's cameras were not CCDs like modern cameras. They were actually Vidicons, television tubes. And these have all kinds of problems with geometric distortion. The way they make images is with a beam of electrons that gets moved back and forth by magnets. And the amount of distortion that happens in these images depends a lot on how much charge is already on the front of the screen. There's a lot of charged particles flying around. And so the distortion changes from image to image to image, which again makes it extremely difficult to line them up. Now, scientists knew that all of this distortion was going to be a big problem. So they solved the problem by painting little marks on the front of the Vidicon tubes. These are called Roseau marks, and the little black dots help scientists line up the images so that they know exactly where the images were taken. Of course, the problem is this results in little black dots speckling all of Voyager's images from all of its encounters. And you have to edit these out. There's really nothing you can do except use a paintbrush to fill them in, which is something that no scientist wants to do, but an artist has to do in order to make these images pretty. There are a few other problems like dark current. That's why space never looks black in Voyager images. And also there are just some blemishes on the fronts of the cameras, so you have little dust spots all over the place. Taken all in all, it is an incredible amount of work to make Voyager images look pretty. But it is so worth it because the Jupiter images are just so gorgeous. So I want to show you two examples of some amazing processing that a couple of space artists have put together with the Voyager images. One takes the approach animation and simply aligns Jupiter so that you can see Jupiter growing in Voyager's field of view, and you see the moon spinning by. Once in a while, you see a little edge of Jupiter cut off because Jupiter had actually wandered over to the edge of Voyager's field of view. But just this approach image is spectacular, and it gives you the feeling of Voyager flying into Jupiter. The other animation that I wanted to show you is perhaps even more amazing. It was made by first creating color composites of the Voyager images. So you have to take orange, green, and violet filter images and combine them into a single color picture. But this space artist got tricky. He only selected those views of Jupiter that had the red spot in the same place. So you get the impression of Jupiter just standing still, not rotating in space, but you can watch all the clouds swirl around as Voyager 1 approaches. So I show you these things to show you how amazing the Voyager images can be, but it is an awful lot of work, and we really ought to appreciate the amazing work that these space artists have done. Thanks very much. I'm Emily Lakdawalla, and I hope you'll join me again next week for another Snapshot from Space.